Good afternoon, everyone, Nana. Yeah, yesterday I think we started collisions. Am I right? Yeah, exactly where I stopped, Nana. The inelastic collision yesterday. Good afternoon. Anyone remember? Note point. Note point means what is that note point? I have to check now. Mhm. What will be that note point? Exactly. Where are the documents? Zoom. Yesterday class. Oh, may or may not be in physical contact in a collision. Very good. Yeah, that is the point. Correct. Exactly. Hmm. Right. So I think you asked yesterday, sir, where the two bodies are not in physical contact. Am I right? That point you asked me. Okay. Yeah. So coming to that point here, what happened? Yeah, here, what is that last point? Oh, I gave an example also. Am I right? Yes, yes, yes. We did one dimensional, I think. Correct. Yes, yes, good. Then coming to here. Now I recollected the things what I said yesterday. And here you asked, pointing me and you poked me that where these two are not in contact, sir. Okay. So for your poke, my response here is yeah, anyone knows here about the Rutherford alpha ray scattering experiment in chemistry, Nana? Yeah. Was that completed in chemistry? Ah, yes, gold foil, Mr. Mani. Yeah. In that gold foil experiment, what I think your chemistry master told, suppose this is the nucleus of one atom inside the gold foil, and this is the alpha particle projected towards the gold foil. Okay. When it comes close to the gold foil, that is close to the atom of gold foil, without touching the atom, it takes a scattering and finally travel like this. If I am not wrong. Okay. Iron racer. Iron race ಎಂತ್ರ ಸಾತ್ವಿಕ alpha racer. Okay, right. Alpha race bombard. Right. Okay, okay. Then it is alpha rays bombarded with the atom, sorry, nucleus of gold foil. There observe these alpha rays, which are positively charged particles, going close to the positive nucleus here. It is also positive. Okay. But it never touches the nucleus, deviates. This is called as scattering, scattered, and then travel like this. There is no physical contact, but it is also called as collision. It is the collision between, okay, alpha particle, that is one alpha ray, and the nucleus of gold foil. There, the two are not. Here, they are not in physical contact. They never touch each other. Never, I'm using the word never. They never touch each other. Okay. So never before, ever after, they won't touch each other. That's why they never in physical contact. But it comes under, it is the collision, already I told here, it is the collision between alpha particle and here the nucleus. Right? This is one type of collision. Right? That's why my statement is valid. Okay, this is practical example. Rutherford observed, Rutherford's experiment, practical observation. So you have to accept, right? So here, when we see in our daily life, the collision between the bike and car, car and car, car and person, like such type of collisions, and in billiard game, snooker's game, ball to ball collision, in caroms game, striker and coin collisions, all these coming under the physical contact collisions, whereas this is no physical contact. There is no physical contact. Okay, so my statement is sustained or ruled out. Millard, my statement is sustained or ruled out. Yes, yes means sustained or ruled out. Sustained. Okay, right, good. Right. So my statement is correct. So may or may not be in contact. That's what I told. This is one example. Okay, where the two colliding bodies are not in contact. In contact. Okay, further it is the diagram. So I explain now. Final conclusion in the statement may or may not be. My statement is correct. Okay, and then here yesterday I think I explained inelastic collision. Okay, where m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Okay, and we did few examples related to it. Okay, if I am not wrong. This is what I explained in the first page, collisions before and after. What I explained in the second page yesterday. I'm just checking, Nana, in my notes. Second page, I explained what here P before is equals to P after one. Yeah, exactly. One dimension collision I explained yesterday. And there I gave one example. In third page, one more example I gave. Yes, that's all. Right, good. So I will everything I checked in Nana here now. Coming to the collisions in that part. Okay. Keep in mind, already I told inelastic collision means M1 U1 bar plus M2 U2 bar equals to M1 V1 bar plus M2 V2 bar. Okay, this is inelastic collision obeying the law of conservation of linear momentum. Okay, related to it, if you come to few questions, what he gave, particularly this year means 2020, okay, not even 2019. One they conducted in the January, other they conducted instead of April in the month of September. I think all of you know, you have that much knowledge. I believe, I trust. Okay, I have lot of trust on my trust. So am I right? Okay, you know it. 2 exams they conducted in mains. Yeah, good. So if you see few questions, what he gave into the, yeah, right. Coming to one example. Okay, be ready, Nana. Are you ready? Will we start? Yes. No. So there are no weapons. What, Manikanta? Not ready? Yes, yes. Okay. Coming to here. First, here the question is, this was given in September, okay, 2020 September, okay, but take care. Mains question means not that much easy. Future boy, yeah. Future boy has no future plans. Two bodies of the same mass are moving with the same speed but in different directions in a plane. Okay. So in a plane, instead of writing everything, two bodies are moving. Simply I write as shown. But keep in mind, he did not give the diagram to avoid the number of sentences here. Just I am giving the diagram. Okay. He said one is moving like this. Second mass is moving like this. These two collide somewhere here. Okay. And he said here, this is the first mass, M1, and it is the second mass, M2. Both have same mass and same velocity. Okay. U1 is equal to, suppose, U. Even U2 is also U. And M2 is also equals to M. Both have same mass here, what he said. M1 is equals to, suppose, M. Same mass traveling with the same speed in the same plane in two different directions. That's what he gave in words. And the collision, they have a completely inelastic collision. There is, oh, there is a completely inelastic collision. Completely inelastic collision means you have to understand that after colliding, completely inelastic means they won't separate, stick together like this. Okay, stick together means the first one travels with 2 meters per second. Okay, the other one stuck to the first one travels with what speed? The second body stuck to the first body. Same. That's what I'm saying. So completely inelastic means you have to understand that they travel with the same speed. That is the point what you have to understand. So here I am writing both stick together. Why? Because he gave completely inelastic, stick together and move commonly with the same speed like this. This is, say, some velocity, what he said, with the final speed, which is half of their initial speed. Means he said V1 is equals to V2, both move with the same velocity. That is equals to half of the initial velocity, U by what he gave. Okay. Then the question is, find here, find the angle between the initial velocities. This is the question. Okay. Given 2020 September 6th, first batch, morning batch, he gave morning shift. Okay. Here, inelastic means we have only one equation in our hand now. Keep in mind. So what you apply here? Anyone has the idea? LCLM. Okay, right, good. Okay, Ishan told LCLM, right, according to LCLM. What do you say directly? Shall I write M1 U1 plus M2 U2 is equals to M1 plus M2 into U by 2? Is it correct? What I wrote on the board, is it correct? Yes, sir. Why, Ishan? No. Since I asked, the answer is no. Not opposite directions, Nana, Ishan. They are traveling in two different directions now. We don't know the directions. Okay, they are not opposite. Okay, one is coming like this, other is coming like this in two different directions. Opposite means like this. This is opposite. Yeah. Formula, okay, Manibabu. Which formula? Tamaraju, here nothing is there to explain, Nana. Here two bodies are moving in two different directions. Like from a gully, one person is coming like this, another person is going on the road like this. They collide each other here. Car collides the bike. No, Rabji. Okay, I think not seriously practicing here. What I understood. Okay. Observe M1 U1. Okay, how you get it as 120? Will you explain if I give a chance to you? Will you explain? Manibabu? Okay, no response. Yes, okay. Then take a chance. Now you explain.
Hello, sir.
Yes, hello. Good afternoon.
Good afternoon, sir.
Yes.
Sir, with that formula, we know that mod P bar equal to mu, no, sir.
Here, first
Yes, sir.
one. Okay.
Then we can use that formula, no, sir. P1, P0 equal to under root P1 square plus P2 square plus P1, P2 cos theta.
Oh, means you are taking the resultant of these two.
Yes, sir.
Okay. Resultant of those two is equals to straight away. Right. Means you are saying that in a complete different way, but I say that I can't deny your method.
As both are equal, no, sir.
Mm,
P1 mod P1 bar equal to mod P2 bar. By that formula, we
yeah,
can.
you said, yeah. You are telling like this, Nana. This is the first particle, mu, what you are saying. And this is second particle going upwards, mu. The finally, suppose the particle comes out like this, means the combined mass after striking here strikes and stick together and comes like this. What you are saying, this is m plus m stick together and come with a velocity, common velocity of u by 2. Are you saying this one only, Nana?
Yes, sir.
which is coming under like a 2m into u by 2. That is equals to mu.
Yes, sir.
Means two equal vectors making an angle theta. Okay, sorry, two vectors having equal magnitude making an angle theta, whose resultant is also equal to the magnitude of either, then the angle between the two vectors is equals to 120 degrees. What we discussed in vectors chapter long back.
Yes, sir.
I think you are saying that point.
Yes, sir.
Right. Means you are using this concept here. Student will ask, sir, I am not asking the resultant linear momentum, sir. How to equate the resultant of these two with the final linear momentum of the combined system? If the student, any one of your friends asked you, then how you explain that one? The resultant of the linear momenta of the two bodies before the collision, you equate it to the linear momentum after the collision. Then how you explain that? You can explain easily. Your method I accept. Why? Because nothing wrong in your method. But explain this method to the student properly. That's what I'm asking. This is P1 bar, Nana. You can explain, Mr. Manibabu. This is P1 bar. And this is P2 bar before the collision. So total linear momentum before the collision is equals to P1 bar plus P2 bar. Okay. After the collision, it moves like this in this direction, which is m plus m. Yeah, you can explain. That's what I asked you now. I asked you have every right to explain. Yes.
So then after it, by substituting in the formula,
Which formula?
resultant, sir.
Again, you are going to resultant. Student is not asking resultant. How can you say the resultant of these two is the final linear momentum? That you have to explain. Okay, I think you are not catching my point. That's why you are not able to say. It is easy. You can say very easy. P after he gave in this direction, Anna, which is m plus m into u by 2. Let it be P bar. Okay. So according to LCLM, P before is equals to P after in vector form. P before is P1 bar plus P2 bar is equals to P after. I took it as P bar. So here, if you take the mod of those two, P1 bar plus P2 bar mod is equals to mod P bar. Now you understood, all of you understood this step, Nana? What I wrote here in pink color? Or any doubt in my explanation? Sure? Huh? Yeah. Here, this part, what Manibabu is saying. Sir, P1 bar plus P2 bar magnitude is, since those two vectors are originated from the same point at an angle theta, this one, what he is saying in the next page, root of P1 square plus P2 square plus 2 P1 P2 cos theta is equals to mod P bar. Here already I calculated, that is m plus m into u by 2. This is nothing but 2m into u by 2, that equals to mu. Any doubt here? Nothing is there, Nana, to explain here. Yeah. Why? Because just I am applying the law of conservation of linear momentum. That's it. What is the total linear momentum before the collision? What is the total linear momentum after collision? That I equated here. Total linear momentum before is P1 bar plus P2 bar. This is total linear momentum before. P after, they stuck together and move commonly. Okay. So here the combined linear momentum, I take it as P bar. Okay, this I got from law of conservation of linear momentum. Now I'm taking the mod on both sides. Magnitude of P1 bar plus P2 bar. This one mod of like A bar plus B bar. That formula in vectors we know, root of A square plus B square plus 2AB cos theta. That I applied here. Root of A square plus B square plus 2AB cos theta is equals to mod P bar is already I calculated here. Mod P bar is m plus m into u by 2. This is after collision, they stick together. So combined mass is m plus m. Move with a common velocity, he gave it as u by 2. M plus m into u by 2. That's it. Srivali, now you understood? Still, do you have any doubt? Yes, okay, right, good. Then here substitute the magnitudes of P1 and P2. This one what Mr. Manibabu explained. Magnitude of P1 means that is m into u. Magnitude of P2 is m into u. All are equal. So directly you can substitute root of here mu whole square plus mu whole square plus 2 mu into cos theta is equals to 2m into u by 2. 2 cancel, that you will get it as mu. So mu whole square, mu whole square, mu whole square, if you take common in all, you will get mu whole square into 1 plus 1 plus 2 cos theta here. Mu square whole square, if I take it out, mu under root of, I will get 2 plus 2 cos theta is equals to mu. Simple, mu cancel. Then root of 2 plus 2 cos theta is equals to 1, cancellation. Squaring on both sides. 2 plus 2 cos theta is equals to 1 square, that is 1. 2 is taken to the other hand. 2 cos theta is equals to 1 minus 2, that is equals to minus 1. So cos theta is equals to minus 1 by 2. Therefore, theta is equals to 120 degrees. Okay, this one actually we should not do. Already we did this derivation in vectors chapter. So straight away without my explanation, you have to say the answer. Sir, the two magnitudes are equal. Resultant is also same, sir. That's why straight away the angle between the two vectors is 120. If you say like that, then you remember the vectors. Otherwise, you forgot the vectors. Okay. Now is it clear, Nana? Understood? Yes, good, good, good. So all of you successfully solved one previous mains question. Okay. Fresh 2020 September 6th question. Okay, good. Now coming to here, one more question. 2020 only, this year only, September only. Okay, same date 6th. One more question in the evening batch, evening shift. He gave here, this is a particle A of mass m1 moving with a velocity m1 is given as m1 only. Okay, is moving with a velocity. Its velocity means u1 is given as root 3 I cap plus j cap. Okay, meters per second collides with another particle B of mass m2. M2 is m2 only. Okay, which is at rest. At rest means second particle is at rest, 0. Okay, and after the collision, here he said the first particle means m1. M1 after the collision velocity means v1. V1 bar, here he said, is equals to I cap plus root 3 j cap. This is v1 bar. Okay, and given that m2 is equals to 2m1. Sorry, m1 is equals to 2m2. m1 is equals to 2m2. Oh, 2m2 na. m1 straight away here I write it as 2m2. Okay, no problem. 2m2. Then after the collision, find the angle between the velocities of two bodies. Okay, this is the question. Means what is the difference between the first example and second example here? What, Manikanda, what you asked, I did not follow. First example, he asked before the collision, what is the angle between the two velocities? Means u1 and u2. What is the angle between u1 and u2? Second question, he asked what is the angle between the two velocities after the collision? Means angle between v1 and v2. Okay. Now you understood? Who will try this one if you understood the question? Who will try? Babus and babies. Anyone, please? Big B or small b? Okay, Ishan. Sure. If you got any idea, please share it, please. I also will try. Hmm. Yes. No one is trying. First, you can share your idea. Later, we will get the answer. Idea, please.
Sir.
Yes, Ishan.
Sir.
Yes.
Sir,
Yes.
can we try LCLM, sir?
Yeah, sure,
Or
sure. According to LCLM.
sir.
Sure, why not? means M1 U1 you are saying.
Yes, sir.
M1 shall I write straight away 2 M2?
Yes, sir.
M1 U1 root 3I plus J. Straight away I'm substituting, Nana.
Okay, sir.
M1 U1 plus M2 U2.
Yes, sir. Zero,
That
sir.
is
Zero,
0.
zero, sir.
Right, good. Is equals to M1 V1. M1 is 2 M2.
Yes, sir.
V1 is I plus root 3J.
2M2 gets cancelled, sir. No,
Still
sir.
one more is there. M1 V1 plus M2 V2.
Yes, sir.
M2 V2 bar. V2 do you know here from the information?
V2, sir. No idea, sir.
V2 is right. So I think you are right, your method. But V2 we don't know. That we can find, I think, from your equation, what you said. Once we check there, we can find in all M2 get cancelled. And we will get 2 root 3 I cap plus 2 J cap here on the left hand side is equals to on the right hand side, we will get 2 I cap plus 2 root 3 J cap.
Sir, taking 2 J
plus
cap to the
V2 bar.
right hand side and 2 root 3 J cap to the left hand side, taking root 3 common
No
in both
need,
of them.
everything. No. We need V2.
Okay.
V2 bar we don't know, na.
Yes, sir.
So better we bring everything to the left hand side.
Okay, sir.
So I cap components are 2 root 3 minus 2 into I cap, correct? By taking
Yes.
this one to the left hand side.
Yes, sir. Yes, sir. Correct, sir.
Plus 2 minus 2 minus 2 root 3 into J cap. Is it correct?
Yes, sir.
Yes. Till here, okay, Nana. According to LCLM, what you said, I found V2. Then what is the angle between the velocities after the collision? Angle between whom? U1 and U2 or V1 and V2?
V1 and V2, sir.
Right, good. Being a mathematics student, generally the student will try 195 Amok. Okay, I don't think it's so. The mathematics student will try to do like what? Sir, between two vectors, we know in mathematics cos theta is equals to a bar dot b bar by mod a into mod b. Correct, Anna? This is from dot product. A dot b is equal to ab cos theta. In the same way, you can find out the angle between V1 and V2. But I think that will be very lengthy. So not being like mathematics student, being like a physics student, smartly we try to solve it. What the smartness the physics student has, sir? Yes, my physics student
Magnitude of V2, sir.
Not magnitude, angle. For a given vector, you can find the angle. No, not 75, not 150, Mr. Manikanta, not 75, Mr. Amok. Here V1 bar I plus root 3J I caught. Am I right?
Yes,
Usually
sir.
it will be in the first quadrant, second quadrant, third quadrant, fourth quadrant. This one. I positive, J positive. First quadrant. Okay, right. So here I will get this one V1 in the first quadrant. This is V1. Okay, right. This is x-axis and it is y-axis, and that V1 is equals to, I know here in the question only he gave it as I plus root 3. I plus root 3. So it makes how much angle with x-axis? Theta 1 I can calculate tan theta is equals to using the formula AY by AX. We know in our physics, vector chapter, AY means √3 by AX, I cap component is 1, tan theta is √3. That implies theta 1 here. Shall I write it as 60 degrees, Nana? Any wrong?
Correct, sir.
My physics, using my physics. Physics student will do like this. Okay. And later, V2. Once you check there, V2, where is it? V2, V2, V2. 2 √3 minus 2. It will be positive. 2 minus 2 √3. Oh, 2 √3 is bigger than 2. So you will get this is negative. J cap is negative, I cap is positive. Positive X, negative Y. It will be in which quadrant? Think wisely. Fourth quadrant. Very good. So turn this one, fourth quadrant. Yes, right, good. Fourth quadrant. Coming to here into the fourth quadrant. This is in fourth quadrant, V2. And that vector I'm taking here. This is V2 bar. Then that one makes how much angle with x-axis I'm going to find out. Surely it will be negative, Nana. Why? Because it in fourth quadrant means angle will be negative. Tan theta will be negative. And this one we got it as 2 √3 minus 2. I cap. Better I write by taking minus common here. If I take minus common, 2 √3 minus 2, I will get again J cap. Both are equal on x component is equals to y component. Then what will be the angle here? Directly you can say. Yeah, total 105, correct. Yeah, here tan theta 2, I can write that is AY by AX minus of 2 √3 minus 2 by 2 √3 minus 2. That is equals to minus 1. Means theta 2 is negative minus 45 degrees. Exactly, that is in the fourth quadrant. That's why I got minus 45. So this is 45 degrees I got. That is 60 degrees I got. So what is the angle between V1 and V2? 60 plus 45, 105. Is it correct, Nana?
Yes, sir.
Angle between V1 and V2 equals to, that is above. This is below, plus 45. Don't write minus 45, Nana. 60 plus 45 all together, that is equals to 105 degrees. This is the answer. Now you understood? All of you? Yeah, Nana, any doubt here? $135. Okay. Right. Okay, no problem. Good. Will I leave one question to you, Nana, for tomorrow? Will you try that? Sure. Okay,
Yes, sir.
good. All right. Then one question here. Wait 1 minute, please. This is 2nd September, Nana. A particle of mass m is moving along x-axis, means m1 of mass m is moving along x-axis with an initial velocity of, means u1 is given as ui cap. Okay, and it collides. Better I say this one. Two particles of equal masses. M1 is equals to m, M2 is also equals to m. Both are respectively initial velocity is ui cap and u2 is equals to u by 2 into I cap plus j cap. Okay, they collide. completely inelastic. Okay, completely inelastic, Nana. Completely inelastic means stick together and move calmly. I already told in the first example. Okay, same type, completely inelastic, right? Then loss of energy means kinetic energy. Loss of kinetic energy in the process is, okay, loss of, keep in mind, kinetic energy. Do you know the kinetic energy formula, Nana? Half mv square. So loss of kinetic energy, already I told, I think yesterday. I told it or not, Nana? Loss of kinetic energy formula. Ayyo, loss of kinetic energy is simple, Nana.
We know, sir.
Yes. Total kinetic energy before half m1 u1 square plus half m2 u2 square. Total kinetic energy before minus total kinetic energy after. After, since it is completely inelastic, combinedly they travel. M1 plus M2 stick together and combinedly travel with a velocity v square. This is equals to how much he is asking. It is the hint. Will you solve, Nana? Will you try?
Yes, sir.
Yeah, first try to find out V. After finding out, substitute all the magnitudes here. U1 magnitude, U2 magnitude, V magnitude. You will get the answer. Okay. Yes, right. Right. If you want the pages, you can take, Nana. This is the first page. Thank you. And this is the second page. This is also 2020 September question only.
So 1 by 8 mv square.
Nana?
1 by 8 mv square.
MV square or MU square?
V, sir.
Okay. Then we will see tomorrow. Okay, this is the third page. Okay. Bye, Nana. Have a great day.
Thank you, sir.
We will meet tomorrow.
Thank you, sir.
Thank you,
Thank
sir.
you,
Have a
Nana.
nice day.
Thank you.